In this video, we're going to cover Lab 9, which is about the Internet of Things and cyber-physical systems. A challenge with dealing with these is that the software runs on specific hardware rather than general-purpose computers, and also there are a number of different operating systems that these devices can use. So IoT differ from normal computers in that they have less resources like memory to operate in and are usually diskless. Having said that, a large number of these consumer devices operate on Linux or Linux-like systems, and that makes analysis of these devices and even software emulation somewhat simpler. These devices also have a pretty poor history of security. One of the principal areas of concern, and one we're going to look at in this lab, are hard-coded passwords that are used for remote access to the devices and leaving the access to these services open by default. What we're going to do is examine firmware, the software that is used to actually boot up and run the consumer IoT devices. In particular, we're going to look at a wireless router device, which is a consumer device made by Netgear and was released for sale in 2010. It's a model WNAP320. It was available for quite some time after that. And like a lot of these devices, if you've never configured them before, have a web interface to administer the device. And they also support remote access using protocols like Telnet. And SSH was not enabled by default. The administration function is normally accessed being on the local network or by using a direct cable to connect to the device. And you can find some of the details in this manual link here. One of the problems with this device was that it shipped with the default username and password, which was a username of admin and password of just password. And you can look up the default usernames and passwords for a lot of devices. That's still problematic today. So we're going to start a container. Let's just start by copying that and running it. And what we're going to do is just go through some of the steps that you would do if you were going to actually try and look for vulnerabilities in this type of software. We'll first of all change to the directory WNAP, and if you can have a look, there is a zip file and a Python exploit file. We'll come to that later. But the zip file is actually the firmware that you would use to upgrade the router. If you wanted, this is a specific one which has this vulnerability, but you can actually also still download this from the website, which is where I got it from. So let's unzip the file first of all. So we use unzip, and we can press tab and it will just complete the name. And then if we do an ls-al, we see that the zip file contains just one file, which was this firmware.tar file. Tar is another type of compression technology, a little bit similar to zip. It's called an archive tool, and we can extract that using a command, a tar command, which is -x for extract vf, and provide it with the tar file name. So if we untar that, what we've got is something which is the Linux image. We have a file called squashfs and then two MD5 files. Those are the hashes of these two files, which you can use to actually verify that they haven't been tampered with. Although, given that we've downloaded a zip file, you could actually substitute these for pretty much anything else. You'd have to check it against an authoritative source. The file we're interested in is this one, the rootfs.squashfs, which is the actual file system that would be loaded onto the device. And we can extract this using a tool that's on the container called binwalk. Binwalk does a lot of things, but one thing it can do is extract squashfs file systems. So if we extract that and do ls-al, we can see that we have now a file, a directory called rootfs squash fs extracted. Because of the color, it's a bit easier to see on the documentation here. So if we cd into that directory and do an ls-al again, we have squash fs root. So let's cd into that, ls-al again, and then we have a lot of different files. And you'll see they recognize that it's the standard Linux file system layout with a bin directory which has applications, etc, which has some configuration files, home, which is where user directories are, and so on and so forth. And you can go through all of those if you want. An interesting feature about these types of devices, because of the nature of the constrained memory that they have, is that they use a thing called BusyBox. And BusyBox is available on a lot of IoT devices. Essentially, BusyBox combines all of the tools and separate programs into one, so you can actually just deal with one single binary. And what we do is actually create the commands by linking to arguments that are provided to BusyBox. But that's just an aside. What we're interested in is we're going to go into the /home directory, and if we do an ls, one thing that you might do is if you do /home, you'll get into the home of the container and not this, so you've got to be careful about using relative paths. So let me just copy that, cd, go back in, ls, and don't put the / there, just put home, ls again, and we've got to CLI and www. www is a common name for web home directories, so let's just cd into that, do an ls, and then we've got a whole lot of PHP files, which are program files that are used commonly to run websites. And there's a lot of interesting information in this, and you can look through this and have a look at what you can find and just how this site works. But this is the site that would be used to run the essentially the web interface that allows you to configure the device. So it turns out that this device has what's called a remote command execution vulnerability, and it's actually called CVE 2016-1555. So it was actually reported in 2016, not that long ago. And you can see that there is an actual exploit for it. These exploit, when somebody develops some code to exploit a vulnerability, it's normally called a proof of concept, or POC. You'll see that I refer to that in the labs and in the project, but you can look at the exploit in there. One of the affected files that's got this vulnerability is one called board data www.php. So if we actually, let's go and have a look at that file, and you can see the code. You can see it's a PHP file because it's got this first line which says PHP. The offending line is this one, which is the exec. Exec basically takes whatever's passed to it and will run it as a command. It's a very bad idea to do this in code, but a lot of people did it because it's convenient. You can just pass it dynamic commands and it will run. So what this is actually doing, if we look at the lab sheet again, is that it's running a program called wr_mfg_data, and it's validating a MAC address. So you can set the MAC address for the router, and what it will do is it will capture that and it will just say, is this a valid MAC address? So it'll pass all of this to the exec command, and that will run that script and then return a yes or no. The problem is that it's vulnerable. So this is what the command would look like if we passed in a MAC address of F8 FFC201FAE5 with a -C1 flag. The issue is that we can put a semicolon after the MAC address that we enter, and that will terminate that command. So it basically says, run this command. That's the full command. It just chops off the end here, the -C1. And then we can insert any command we want after that. And in this case, what we're doing is we're copying /etc password, the password file, to a file called test.html. And then we terminate that one with a semicolon so that it doesn't get confused by the remainder of the text, which is this -C1. Exec will try and execute that. We'll basically say, don't know what the hell that is, because you can't pass that to a command, and it will just fail, but that's okay, we don't care. So we then can, once we've copied password to that, we can just simply do a fetch on that file, and we'll get the contents of the password file. Now you can pretty much do anything on this system using this, including putting malicious code, malware onto it, or basically doing what's called a reverse shell. That means you can essentially allow for remote access through a shell by running a shell and waiting for connections to it. Now, normally you would mitigate this by whenever you take input in the form of one of these sort of input boxes, you sanitize it, which means you look for things like this. If you know that this type of function is vulnerable to this type of attack, then you would code it in such a way that it prevents this from happening. So you would make sure that MAC addresses are only a certain length long, and you would make sure that the input is never longer than that. That's one way of doing it. The other way of doing it is because technically we could just put a semicolon after the first character. You could then sort of look for text that are typically used in commands and get rid of that. So we can test the exploit by, let's just come out of this file, by going to back to this root, and we've got the file exploit.py, and if we have a look at that, you don't, as I said, you don't really need to be particularly familiar with it, but what it's doing is it will print out the flag for you. What it does is that it creates, it's going to actually access this file that is running on a machine under emulation, because it's difficult to set up. I didn't ask you to try and emulate it yourself, but we're doing it for you. So it's running the actual code for this firmware, and it's passing in a MAC address, and then it's going to pass in essentially the command that we give this exploit file, and then we're going to write that out to test.html, and then we can then fetch it. So it pretends to sets up a request. It does the request here using a post, and then it tries to get the test.html file and returns and prints the results of that out. So if we quit that and we just run exploit and then give it a file we want to read, and remember that this is reading this file from the server that's running this firmware under emulation mode. And there we go. So we have the password file that's returned, and this shows you all the users that the firmware knows about. Admin, for example, that's the only real user. There's a SSH user and other things. So you can run the exploit again, passing it the flag argument, and that will do that. But hey, what the hell? If you've watched the video, you can have the flag. So that's one type of firmware. Let's look at another one, and another type of vulnerability that we can discover. So in this directory, there's another one. This is a D-Link wireless access point or wireless router, and it's the dir300. So let's just go into that. And this time, it's not a zip file, it's a .bin file, which is another format for firmware. And again, we can use binwalk to copy this. And extract it. Okay, so that's given us a number of things, and it's given us an extracted directory. So we can go in there, and it's given us another squashfs directory. Sorry, no underbar. Called squashfs root, and if we ls, then we're back into, again, another thing. Notice that the www directory here is not under home, it's under www, but if we go into home, let's see what's there. There's nothing there. Oh, I've done it again. Sorry. Just have it. Let's just paste that. Yeah, so there's nothing there. But if we go into www, you'll see that again there's a whole bunch of PHP file that is used to run. Let's go back up again. What we're going to do though is we're going to actually just look for this, in this case, the word telnet. So we're going to use a tool called grep, which essentially will read all of the files, and we give it the flags -i, which is ignore case. And so that means we can find matches of telnet which are uppercase, mixed case, etc. And R, which means recursive. We'll look through all files, types that we have with the star or asterisk, and then we're going to look for the word telnet. So if we paste that in and run that, and here we go. So we've got a whole bunch of files that mention telnet. So the interesting one that we've got, and let's have a look at this because it's just a bit easier to look at, is this script file, which is telnet-d.sh. And that's got a thing which is called starting telnet. So it's going to run the telnet daemon. And it runs telnet daemon, passing in essentially a login script. And it passes in the user, which it's so we're given the user, it's Alpha Networks, and the password is $image sign. So what we actually are interested in is what is that password, and so essentially what that is using a variable. So somewhere in this script that variable is set, and if we look at the script of this file, so look at the script there, what we see is that it's actually setting the variable image sign to the contents of this file, which is set etc config image sign. So if we actually cat that, what we get is this, and that is the password that's used for telnet. So essentially they've hard coded it, and we now know that if telnet is ever enabled on these devices, that the password username would be Alpha Networks, the password would be this. And it turns out that actually D-Link used a reasonably small set of these passwords, and so it's actually very easy to go through the different options. They made up of things like the model name, and this changes a little bit but not very much, and so you can actually guess it. So that's really all you need to do is put that password in, and you've done that as well. I encourage you to have a look as well at all of the other things in this and explore a bit more, because it gives you an opportunity to see what it's like to actually look for these types of vulnerabilities. Also, we can just show you. I can just show you if we go back into samples and go into WNAP. And cat exploit. If we actually have a look at the URL that we're accessing, let's just have a look at the full one. Oh no, let's just look at this one. So we just copy that and go here and have a look. Hopefully what we should see is the software. Because it's running under emulation mode, again, it's running on a specific type of chip, so you can't run it. And this is what you would normally see when you actually use this access software in your router. And so we can type in admin, password, and log in. We don't want to save that. And that's the default username and password, and it gets us into the Netgear configuration tool. Clearly this is running under emulation, so it's not doing anything, but this is how you would normally set up your wireless router. If you've got a wireless router at home, have a play with it. Find out which IP address it's on, and have a look and explore. And have a look and see if there are any existing vulnerabilities. Has your home Wi-Fi router ever been updated? How would you go about updating it? These are all things that are sort of worth pursuing. All right, well that's it for Lab 9, and we'll look at Lab 10, which is AI next. Thanks.